already. All right, so on the study sheet, I kind of hinted the other day already, when it comes to logarithmic regressions, you're going to get a table, either horizontal, vertical. You go stat calc. This is what I want to draw your attention to. It's ln reg, not lin reg. Okay, it's not going to work if you do lin reg. It's going to be a linear regression. You don't want that. So please don't mix that up. We don't have log reg. We don't have. So the only way to do a regression is using natural log. And natural logs are based on E. The base is E, okay, which is 2.71 something, okay? So let's do this one here. I will highlight that so that I remember, that I know that I've covered it. So it's a natural logarithmic function, and your equation will look like that when you do regressions. Okay, we're going to use ln reg, ln reg, not lin reg. The flash on most digital cameras requires a charged capacitor in order to operate. The percentage charge Q remaining on the capacitor was recorded at different times, T, after the flash has gone off. Okay? T5 flash duration represents the time until the capacitor is only 50% of its initial charge. T5 flash duration also represents the length of time that the flash is effective to ensure that the object being photographed is properly lit. Okay? Construct a scatter plot of the data given. So we're going to put this into L1 and this into L2, which means this is X, this is Y. Let's make a scatter plot first. So it's 100. Go ahead and enter that. You do that. And then we do the next. If you want to look at the scatter plot, if you want to look at the scatter plot, we go, do you remember how to do this? Clear anything that's in your Y, we turn on plot 1, and then I will do a zoom 9, which is zoom statistics. And you can tell that, can you tell what kind of regression this will be? We're an exponential logarithmic, so basically we're trying to narrow down between those two options. Is it possible that this is an exponential? Let me see my study sheet. Exponential. There's a horizontal asymptote. What does that mean, horizontal asymptote? I don't even have that on here. It means that it never touches it, right? So while we're at it, or did I put it somewhere? I'll just, next to exponential, somewhere, never touches x-axis. Exclamation mark, okay? The exponential never touches the x-axis. Okay, so that's good. Let's go to logarithmics. Which axis does it never touch? Never touches the y-axis. Why am I emphasizing this? because you can rule it out if something were to happen. If you see that a certain scatter plot is touching my y-axis, it cannot be a logarithmic, right? If you have a certain one touching the x-axis, it cannot be an exponential. Does this touch the x-axis? It actually does. Like, this is my x-intercept, okay? So I will say this. Plot shows a decreasing function which touches the x-axis. It's the point 100, 0 right there. Okay. Therefore, it has to be a logarithmic function. In fact, if you try to do an exponential, 46. If you try to do an exponential, you get an error message. Like it will not be able to do it. Okay. Okay. So I will make my point even stronger. Once you do the zoom stat, I'm going to adjust my window real quick. -5 for x min. And look at the value for y max. It's very, very small, right? The y max. So don't be going -5 here, because you're going to see a lot in the negatives, and you don't really want that. So I'm actually not going to touch the y max and the y min. So this is a pretty good scenario. You see the y-axis, okay? And so we now know that it is a logarithmic, okay? So it does tell us. Remember, most of the time they will tell you anyways. Determine the logarithmic model. So we're going to go stat, calc. We're going to do logarithmic, not ln, but ln, right? Second 1, comma, second 2, comma, alpha trace. And so you go stat, calc, ln reg, 0.446, right? 0.46 minus 0.0. This one is going to be tricky, so I'm just going to go more decimals. I'm going to go 0.0998, because the 4 doesn't affect the 8. So I'm just going to leave it there. Don't forget ln of x. Don't forget the y equals. Don't forget the x variables. Don't forget the x squares or anything like that, because you lose half a mark. So that is my equation. So let's graph this. And there it is. We can go a bit higher on the y max, but don't go too much higher, because then it's, so maybe 0.5 or 0. Let's try 0.9 for my y max. See, then you see a bit more at the top here. Okay, so that's a pretty good graph. Use your logarithmic model to determine T5 flash to the nearest hundredth of a second. What is that? T5 means 50% charge left. Anybody into photography? Does this mean anything to you, the capacitor? Well, you don't have to know this to be a photographer, to be honest, but did you know that, have you ever opened up electronics and seen like little cylinders, like little black cylinders on the boards? Have you ever seen those little black cylinders on the boards? Do you know what I'm talking about? They're capacitors. They actually keep energy stored. you can actually get zapped pretty good. Like when you solder around, like you can get zapped. It's not going to kill you, but it's going to scare you. So a capacitor absorbs energy and then it releases it, okay? So a capacitor can absorb 100% of the charge, and then when you take a picture, it will release that energy to illuminate your scene, whatever you're trying to take a picture of, okay? So a T5 means that there's 50% charge left. When I tell you charge left, which variable are we talking about? X or Y? It's X, because that's the percentage of charge. Okay? So in this case, I know this is weird. I know this is probably not something you're comfortable with. You don't experience this on a regular basis, but I'm trying to get you to just think of it this way. No matter how weird it gets, remember, figure out your X variable, figure out your Y variable, and just plug it in where it's supposed to go. Okay? So 50% charge goes here, and they're asking you the duration. How long is that going to take? Okay? The time in seconds. So what do we use when X is given? Second trace. Second trace. You remember that joke? Disappear without a trace. Did I tell you that one? The magician that disappears. No? Later. I don't want it to be on the video, because they're too bad and my ratings are going to go down. 0.0, let's round it to 7, right? Seconds. So this happens really, really fast, right? So you have to be comfortable with really, really big numbers and with really, really small numbers. Okay? You just have to be comfortable with that. This is, if you want more practice, page 50 to 54. 50 to 54, yeah. I'm just going to check if I moved anything on those pages, because sometimes I do move things around. No. So 54, for example, has a logarithmic scenario, okay? So you can try that. This has exponential logarithmic mixed. So there's some doubling time. I want you to spend a little bit of time right now before I let you, I was going to do the AC next. Can you match these equations to the graphs? You can talk to your neighbor. So what I want you to do is I want you to write down the equation underneath each graph. Got it? I'm mixing up cubic, quadratic, so the polynomials, and exponential logarithmic. Give it a try. No, it'd have to be something other than this, a bit harder. Okay, let's do this. Some of you are still working on it, right? I hate to interrupt you, but I also want to make sure we get things done, okay? So, log, you've got two logs here. So why don't we go and figure that out, which one belongs to which one? Which one of these 6 graphs is a logarithmic graph? C, right? And E. What is A equal to here? A is equal to 0 for this one. B is positive because it's in front of ln, right? So this one is going to do something like this. What about this one? A is equal to 5. That's A. B is positive. I don't really care what. So this one, unfortunately, they're both doing the same end behavior. They both have the same end behavior. But what does this one have? What is the difference between these two? This one has a 0.15 because of this. This one has a 0.10. So that's how you can distinguish between the two. So let's go and find our logs. These two are logs, right? Logarithmic, logarithmic. 1, 5, this one is 1, 5 right here. Okay, that's why I'm going to grab this one. Okay, this one right here is going to be the equation for this. And I make you do something like this on the take-home quiz as well. And then therefore this has to be the other one. But if you do 1, 0, this is 1, 0 right there. So this is y is equal to ln x. Could it be that the provinces gives you this ever? Yes. I would not rule it out. A is just simply 0 in this case. Okay, so these are taken care of. I don't have to worry about those. These two are exponentials, right? How do you know they're exponentials? Because x is the exponent. Exponential is this one and this one. Okay, I know that those are exponentials. I know that a is equal to 1 here, like 1 in front, and b is greater than 1. This one is increasing. So we know it's increasing like this. This one is also a is equal to 1. B is greater than 1, so this one is also increasing. So that doesn't make it any easier, does it? How do I do this one? This one you would have to remember. Which one do you think is y is equal to 5 to the x? Which one is going to be steeper? 5x or ex? 5x is going to be steeper. Okay, so y is equal to 5 to the x, and this one is y is equal to e to the x. Okay. One more. How could you have done it differently? Just on my desk. When x is equal to 1, when x is equal, what's 5 to the power of 1? 5, right? So you could have put a 1 in there, and then you know that when x is equal to 1, y is equal to 5. That's another way of doing it. So, okay, now I'm left with the last two. I mean, come on, guys. This one is a quadratic, and this one is a cubic. And this one is these aren't dead giveaways here. This is my cubic here. So this is y is equal to x cubed 5x squared plus 4x minus 5.1. And this one is therefore 0.5 x squared plus x minus 6. Okay, so a little